So next is the infinitely distant light sources. As I said you earlier in the previous video, the example for point source sun. Whenever you are taking such a example, a large light source such as sun that is very far from the scene can also be approximated as a point emitter, but there is a little variation in the directional effects. Okay, approximation for such type of light sources, that is sun, because of the because of the distance matters, isn't it, between the light source as well as the surface. The light path from distant light source to any position in the scene is nearly a constant value. So this is what exactly we are going to take. Here is a sun, consider sun as the distant light source. So again we are taking it as a point source only, but it is there at certain distance from the object, right, in terms of lakhs of kilometers, say, whatever it is. So here is the object and here is the light source is. This is what the diagram they are saying, or they are giving to explain about the distant sources. We can simulate an infinitely distant light source by assigning it a color value and a fixed direction for the light rays emanating from the or emitting for the source. The vector for the emission direction and the light source color are needed in the illumination calculation, but not the position of the light source. Here position we are not considering because we are already we have assumed that the light source is there at certain distance. So we are taking the distance value only for calculation purpose as well as y vector representation purpose. Okay. The intensity, radial intensity attenuation comes here for the distant source, since you have to consider that distance value as radiant energy from the light source travel outwards through a space. Its amplitude at any distance, say d1, from the source is attenuated by a factor. So this is what distance factor they are saying, 1 by d square. A surface close to the light, the light source receives a higher incident light intensity from that source than a more distant surface. However, using an attenuation factor, that is 1 by d1 the whole d1 square, 1 by 1, or you can say 1 by d square, with a point source does not always produce a realistic picture. However, we can attenuate the light intensity with an inverse quadratic function of dl that indicates a linear term. So the inverse linear term, the quadratic function, radial intensity attenuation function f, radian attn it is marked as, so radial intensity attenuation function f, which can be represented as the reciprocal value of, that is 1 divided by reciprocal value of, or 1 divided by a naught plus a1 d1 plus a2 d1 the whole square, where a naught, a1, a2 are the coefficients, numerical values, and can be adjusted, they can be adjusted optimal use it to adjust the attenuation value of the intensity. We cannot apply intensity attenuation calculation 1 to point source at infinity, because the distance of the light source is indeterminate. In case of infinite light sources, or distance between the light source and the model is infinite, in that cases we cannot apply this function. Okay, we can express the intensity attenuation function as follows. So intensity attenuation function for uh, radial intensity attenuation f rad attn, which is 1 for what, if the light source is at infinite distance from the object. Otherwise you have to use this formula, that is intensity attenuation function 1 divided by a naught plus a1 d1 plus a2 d1 the square, where a naught, a1, a2 are the coefficient values, they are used to adjust the or set the attenuations, right. That is for the local light sources, wherever the light source and object, distance between the light source and object is finite, say 1 meter, 2 meter, 5 meter, 10 meter, whatever it is, whenever it is finite, in that cases you can adjust the, in that case you can calculate the intensity of illumination, right? Whenever the distance between light source and object is finite. In case of infinite, just consider this value as 1. That's it. Forget about the denominator value. Otherwise, it will be 1 divided by some value. That some value is what? A0 plus a1 d1 plus a2, sorry, a2 d1 the whole d1 the square. That's what the thing is. So that is all about the intensity attenuation function. Next type of the light source is the directional light source and spotlight. Let us discuss about them in the next video.